Hello students, welcome back. So in the previous video we had talked about your log linear model. So in this video we'll be talking about your semi-log models. So in the log model, both your x and the y variables were in the log form. So in this semi-log model, which can also be called your which can also be called your let me just change the color, log lin model or your lin log model. Okay, so why? Because semi means half, so only one of the x or the y variable will be in the log form. That is why it is called the semi-log model. So either the x variable or the y variable can be in the log form. So when the y variable is in the log form, then it's called the log lin model. And when the x variable is in the log form, then it is called the lin log model. Okay. So what is the use of this model? Why do we use it? So basically, it is used to measure the growth rate of economic variables. Okay, so we'll see we'll see how this model is used and why this is important for us. Uh, okay, let's see. So suppose there's a situation where we want to find out the growth rate of a variable, say your personal consumption expenditure. Okay, on services. So whatever personal consumption expenditure that you're making on services, I want to track the growth of that expenditure over the years. Okay. So this is my y variable, and since I'm tracking it over the years, so my regressor is the time here. Okay. So the x variable will be the time factor. Okay. So yi is the real expenditure on services at a time t. Okay. Y naught is the initial value of expenditure on services. So we know how a variable grows, and at a given time t, the growth rate or the value of a variable at a given time t is basically dependent on the initial value of the variable. Okay, so it can be represented by this equation where r is your compound rate of growth of y over the time period that I'm looking at. Okay, so whatever years of time I've taken, maybe 1, 2, 3, or 4 years, in that entire period, what was the compound rate of growth that is being captured by your r variable. Okay, so this is the equation that we need to use, right? And that we need to work upon. So in order to work and estimate the uh, parameters, okay, so we'll have to convert it in the regression form. So I'll take the log on both the side. Okay, so ln yt is equal to ln y naught t into ln 1 plus r. So this here is actually your coefficient. Okay, beta 2, this is your beta 1. Okay, and time here is basically your regressor. Don't be confused. Okay, so this is not your regressor, the time variable is your regressor. Okay, so I've denoted ln y naught by beta 1 and ln 1 plus r or log of 1 plus r by your beta 2. So my equation becomes this in the log form, and since only the y variable is in the log form, that is why it is called the log lin model. Okay, log lin model, right? And if I add the error term here, this is my regression equation that I'm accustomed to seeing. Okay, so this is the equation. So I'll have to if it follows the assumptions of CLRM, so I can estimate the parameters using the OLS method. Okay, right. So through that method, I'll get the value of beta 2, and now we'll have to interpret what beta 2 is. Okay, so if I differentiate the equation, this equation that I've written here, if I differentiate this, what do I get? So 1 upon yt into del yt upon del t. So this is the differentiation of log yt with respect to delta t or del t, that is time. And similarly, this will be 0 and I'll only be left with beta 1. So beta 1 becomes, if I transform this, so this is basically your del yt, this is t, not e, del yt upon yt upon del t. So uh, this is basically representing a relative change in y variable. This delta y at time t upon y at time t, this is basically a relative change in y, okay? And delta t is basically your absolute change in x variable, which is t here, that is your time, right? So this implies that beta 2 measures the relative change in y variable for a given absolute change in your x variable. I hope this is clear. Beta 2 is basically measuring the relative change in y for a given absolute change in x variable. And if I multiply this relative change by 100, it means I'm doing this. So this is also being multiplied by 100. It means that we get the percentage change in y for an absolute change in x. So if I have an equation where beta 2 is given, so if I multiply that value by 100, so I'm basically getting the rate of change of the y variable, or the relative rate of change of y variable with respect to my absolute change in x variable. So in a way, it is basically talking about the rate of growth, the rate of growth of y variable. Okay, just give me a moment. Yes. So it's basically talking about the rate of growth of y for an absolute change in x variable. This value beta 2 into 100. Okay. So you'll have to transform the equation, transform your beta 2 variable when you try to interpret the regression equation and the estimators. Okay. And if you multiply it by 100, you'll get the growth rate of y variable with respect to the absolute change in x variable. So beta 2 is basically representing your instantaneous rate of growth. So if you're measuring uh, the rate of growth for every year or every quarter, so it will talk about the instantaneous rate of growth at that point of time at which it is being measured. Okay, but if I want to find out the compound rate of growth over the entire period, I'll have to make certain calculations. So basically, my beta 2 is representing my ln1 plus r. So I'll take an anti-log of beta 2. So this is equal to now 1 plus r. And if I shift 1 this side, it means that my r is equal to 1 minus anti-log beta 2, which is actually your compound growth rate for a given period. So uh, I hope this is clear. What beta 2 represent, what is the interpretation, and how you can find the compound growth of rate using certain changes in the equations. So this was about your log lin model. I hope this was clear, and I hope now you see the beauty of this regression equation and this subject econometrics, how you can use it to interpret or to find different variables, economic variables. Okay, and yeah, so that's how it is. So I hope you enjoyed. So I'll see you soon in the next video with another interesting and important topic. So till then, take care. Thank you.